للجميع المشاركين والحضور الكرام في فعالية أسبوع الاستدامة العربية. أنا اليوم معاكم الدكتور راشد محمد كركين، وبإذن الله أدير فعالية اليوم تحت عنوان الإبداع والابتكار في تكنولوجيا الطاقة. And good morning everyone, and first I would like to thank all the participants and attendees today in the Arab Sustainability Week. I am Dr. Rashid Muhammad Karkeen, and I'm honored to be here with you for this session under the title of the Creativity and Innovation in Energy and Technology. I think if everybody is fine, instead of me switching to Arabic and English, can we just speak in Spanish? No, I mean only in English. Is that okay? Yeah? Only in English, if you can, okay?
Spanish.
Okay. So there is a little bit change of the timing today, and all the presentations are now assigned only 15 minutes, okay? So just because of the fact that today is a Friday, and a lot of you have taken your weekend to be with us, we really appreciate that, and then we have prayers time. So the presentations are now, the timing has changed from 20 minutes to 15 minutes. And I hope everybody is fine with that, right? Just give me confirmation so I feel happy that you're okay with that. Yeah, thank you, thank you. That's really good. Okay. And also thank you to everyone who is here, and extra thank you to everyone who has the camera on. Okay, it really makes me feel good, because if I am the only one, I feel like I'm talking just to myself. But the more cameras, I feel relaxed. When I'm relaxed, you don't feel me like, you know, annoying to you also. Okay. Okay, so the presentations are now 15 minutes, and everybody has the agenda. And with all that, I think I will try to remind you once you have 5 more minutes left. Okay, so we will go 15 minutes, and at the end of everybody's presentation, which we are expecting to have 8 presenters, inshallah, we'll have some questions and discussions together. With all that, I would like to request Mr. Samir. Mr. Samir Ghafri. Sir Samir, are you with us right now?
Yes, Dr. Rashid, I'm here with you. Thank you so much.
Samir, how are you?
Very well. How about yourself?
Good, thank you. So Mr. Samir will talk about artificial intelligence and IoT driving sustainability. And I can't wait to see your presentation. You may proceed and start.
Thank you very much, Dr. Rashid. It was very interesting listening to you. The thing is, I don't think the sharing option is enabled for me.
We have an IT support here. Muhammad, can you assist with this, with the sharing option, please?
Yeah, now it's okay. Yeah, let me quickly share my screen with you. Please give me a confirmation once you are able to see it.
And thank you for turning your camera on. It's
most welcome.
So pleasant to see others.
Right. So I hope everyone can see my screen.
It is, I can see it, yes. And it's the video and audio, they're all clear. You may start that. So 15 minutes, please, yeah?
Right, yes. So I will try to make this as short and crisp as possible. First of all, again, thank you very much to the organizers, the Environmental Center for Arab Towns, Clean Energy Business Council. This is a great initiative, and it has been a very enriching experience in the last 1 week listening to all the learned people out here. So first of all, I would like to thank everyone for their presence. Now, coming to the discussion today, my background is specifically OT. We see artificial intelligence being deployed everywhere, all around us, whether it is social media, whether it is smartphones, electric vehicles, and so on, music apps, everywhere you can see artificial intelligence being used. But one area which is very much overlooked is the production, manufacturing, or the OT space, where artificial intelligence and other modern technologies are actually paving way for a much more sustainable society, a sustainable infrastructure. So For the next 10 minutes, the focus would be to look at these areas, how AI and IoT are impacting productions, manufacturing, and in fact, even buildings to pave way for a much more smarter and sustainable world. Yeah. In terms of defining artificial intelligence, now, to put it very simply, artificial intelligence is nothing but simulated intelligence in machines. So we try to replicate what humans being can do in machines. And these machines are not only robots. I mean, whenever we think of AI, we think of robots. We are essentially talking about computers, laptops, servers, or GPUs, which are basically hosted across the world in different regions, and they are empowered with simulated intelligence uh, for them to act like human beings, to take decisions like human beings. There are several components of AI depending upon the area of focus. For instance, computer vision, which is mainly related with cameras and feeds and analysis of different kinds of camera feeds and videos to come up with some sort of conclusions and analysis. Then you have artificial neural networks, you have deep learning. For us, the focus today would be to look at artificial neural networks because that is predominantly used in the OT world today to bring about a lot of difference. In terms of where all we see artificial intelligence being used today, we talk of smart infrastructure, everything that you see on your street, from parking, from lighting, transportation, the way we dispose of our waste, the way smart homes are structured. We can turn off lights and equipments by simply giving an instruction to Alexa. All this is powered by somewhere an AI engine, and the underlying architecture of this infrastructure today happens to be IoT devices, which are essentially collecting information from different types of different types of equipments. And then this information is basically passed on to an artificial intelligence engine, which is then taking decisions and making things easier. If you look at the typical architecture, what you see here is I have tried to give an example here in terms of what we call IoT devices. So at the bottom, you see AC units, you see chiller plants, you see fire alarm panels. Now, this could be anything. This could be lighting equipments. This could be a factory. This could be a building which is equipped with sensors. So the base, the level 0 is always with the equipments and the sensors, where the IoT devices are deployed in order to collect information, and then further, this information is essentially passed on to the data layer. I would call this a data historian, where the data set, since we are talking about tremendous amount of data here, often referred to as big data, it requires a special space to be stored. So these special spaces are often referred to as data historians, which are essentially trying to optimize the way storage is done in servers without compromising on the hardware specs too much. Right? And then from the data historian, the information is pulled by an engine. You can have your analysis engine in form of AIs or deep learning engines, depending upon the application. And this information is put to use in a very efficient manner by the engines which are there at the top level. These are predominantly hosted in central command centers or control rooms, so to say. In terms of getting very granular, because a part of the agenda said how it all works. So just to put it plainly, we have the sensors at the bottom field, or which we call as level 0. These sensors are pushing information to the IO cards. These are input output cards connected to a controller. So you see here PLC, which is nothing but a programmable logic controller. This could be a BMS controller if you're talking about buildings, or any controller which is controlling. So all the information is collected through sensors and is fed to the PLC. PLC is essentially the brain of this control system, where all the logical operations are being written, all the calculations are done. And then after that, the decision is made in terms of deciding what parameters to be left on, or if it's analog, how the value is to be adjusted. All this decision making is done by the PLC. And last but not the least, we have the visualization, which is the supervision level, where we essentially call this the SCADA level, where you have the operators sitting or the plant managers or the supervisors sitting, and they are able to visualize what all is happening in the entire control system. So this is a small, basically a small way in which we can represent what is happening in the control system. In terms of applications, I would try to highlight predictive maintenance. So a lot of use cases for machineries. Earlier, what used to be done was there was a term called preventive maintenance. Even now, you'll see people are going out to the field. They are checking different types of instruments and assets for which for their physical presence and physical presence is essentially required. But now, in the modern era, with the use of IoT and AI, we are talking of predictive maintenance, where we can get information directly from machines about the health of the machines themselves, and then decisions are taken accordingly by the AI engine in terms of when the maintenance activities have to be carried out. We look at green production, water management, and buildings as well. So this is a typical example that you see. This is basically a slide of a live project, which is showcasing turbines or wind turbines in different parts of the world. Essentially, you see here Austria, and these images represent what is the kilowatt rating of these wind turbines which are in action right now. So what the system is essentially doing is collecting critical parameters of these windmills. Now, instead of windmills, it could be any asset. These could be electric cars. This could be a chiller system. This could be a factory with machines. It essentially boils down to how you sensorize the equipment and get the information up to the highest level. So critical parameters are always, gauged through different sensors using advanced SCADA IIoT, and it is fed into an AI engine to determine the health of major asset classes, so that in case of any major problem, we know upfront that turbine A is likely to go down because of this particular problem, and we can arrest the problem before it happens. So it's really impacting the way we consume electrical energy today. We are in a better position to know what is the demand of electricity, what is the supply and demand, which was essentially unknown, and companies were or utilities were overproducing or underproducing in the former years. Yeah, this is another example, an aerial view of different areas where you can see multiple assets. So as I mentioned, a turbine is just an example. This could be any asset. Now, in terms of what AI's role in production, especially in process industry, I mean, essentially we talk of production of milk and other, processed foods, wherein we deploy AI engines these days to do root cause analysis. The engine is able to determine if there is any non-linearity between a golden batch and the batch being produced, and then it is able to pinpoint to a precise reason why there is a problem and how it has to be adjusted. So there is a lot of work being done using AI in the process industry. You see here a small example of how basically there are modern softwares available in the market today which are able to completely automate the complex process of data processing, data production, cleaning, mining, and so on, which was essentially done by a data scientist in former years. All this process, the complex tasks are automated with the modern day AI platforms, and you can actually use AI with no codes without having to learn any special programming languages. It has become a commodity really these days using AI. One of the examples that I can cite here is in case of motors. We all know that motors essentially run the world. Every factory, every building has motors, and to gain insight into the health of the motors and to learn if a motor is likely to fail in 3 to 6 months is essentially what we are able to achieve with certain technologies that you see here. So in this case, you see we have deployed a device here called the motor defect recorder, MDR, as you can see. This device is basically collecting information. The voltage and the current signature of the motors is being read by the MDR. Instead of the traditional way of doing it is by mounting sensors on the motors by condition-based monitoring, but this is a new technology in which there are no sensors required to be mounted. The information is just collected via voltage meters and current meters. We study the current signature. All this information is fed to a cloud platform where a deep learning engine is running, is embedded, and therein the information about the health of the asset, whether it's a mechanical problem, whether it's an electrical problem, predictive insights are available, and you have detailed reports about what happened with the motor, about the energy savings. So essentially, the entire conditioning of the motor is known to you in a matter of minutes if you deploy modern day solutions such as these.
Samir, you have 4 minutes.
Right. So I would now cover sustainability with water industry. Leakage of water has been a major problem around the world, but with the use of AI and IoT, especially the IoT, the role of IoT here is predominant in this case. We deploy IoT sensors on different parts of the channel, and we are able to analyze the leak points very efficiently, and as a result, a lot of water wastage is avoided via this technique. In green buildings, again, I would say just a moment. In this case, I think I would, if I have last 4 minutes left, I would probably show something in the platform. So what you see on your screen, I'll use the last 2 minutes efficiently to show you something real time live. This is a platform. This is an IoT platform wherein if you look at this one, this is an operational hotel where we have taken raw data from the hotel. If you look here in the engineering metrics, if I click here, all the rooms, you get clear-cut information because we have mounted IoT devices here, whether the room is occupied, whether the balcony sensor door is opened or closed, what is the temperature of the room, who is present in the room, whether it is a guest or whether it is a housekeeping staff. Accordingly, the profiling of the energy profiling of the hotel could be done by using the AI engine, which this data is all fed basically to an AI engine, which is taking decisions to control the energy or the amount of cooling in the rooms. In this case, you can see statistics around I think I would say energy savings. I would emphasize here on energy savings. So you see here what is the savings of a particular room. You can select the date. You can select the hotel if it's a multi-hotel site infrastructure. All this is possible in this case. So you get a very clear-cut view of how the energy is being spent and how sustainable really your hotel is. So with that, I think I would conclude the presentation here in the interest of time.
Thank you so much, Mr. Samir. Well within the time, and I will do this. We will go.
Thank you.
Sure, we appreciate that. We will go to our next presenter, Mr. Sam or Sam Lee. Do we have Sam Lee with us right now? Sam?
Yes, I am with you, Doctor.
Sam, how are you today?
I'm good. Let me just turn on camera.
You could start see, that feels a lot better to see everyone. I'm telling this now since the beginning of the
Absolutely. I hope I'm in frame.
Sam, you're talking to us from China right now?
No, I'm actually in Dubai.
Oh, in Dubai, okay.
I've been based here since March of 2021, so just over a year.
Okay, very well. I used to fly to China very often, and I miss that. And the most thing I miss is the hot pot. Okay, I should say that. Very sustainable food. Okay, you can start your presentation. So Sam Lee is the Dean of the Software Institute Blockchain Lab, China Academy of Science. And you're going to be talking about future of blockchain as pathway towards smart and sustainable built environment, right?
Absolutely. And this, again, I really appreciate the opportunity to speak today. Unfortunately, I don't have any smart city and blockchain use cases for the Middle Eastern region, but prior to coming to the Middle East in March of last year, I was in China for 2 years. And China Academy of Science is where I've gained significant exposure and experience to deploying blockchain into, smart cities and sustainable planning. So thank you so much.
Very well. Okay, so now the 15 minutes, the time has changed from 20 to 15, right? So then I will try in between to give you a reminder.
Wonderful. Thank you so much. So, shall I begin now?
Yes, please. You may start right now. Yes.
Wonderful. So again, thank you, honored guests. Thank you, Doctor, for the invitation. The background of blockchain technology came from Bitcoin, which is the first use case of blockchain that was invented by an anonymous individual called Satoshi Nakamoto back in 2009. So this technology, in a nutshell, is providing an immutable ledger that allows for data to be stored safely and securely, and also, more importantly, transparently. What I mean by transparency is that once data is inputted and brought into a blockchain, it can never be changed. It is there validated by the thousands of nodes to be secured and recorded into history. And so the opportunity that presents is for the first time in human history, we can not only create and send data, but we can now create and send value. And so the difference between data and value is when I send and receive data, it only appears to be replicated amongst all the peers I send it to. So what that means is everybody all of a sudden has 2 copies of the same piece of information. That means scarcity is not something that can be solved through, the existing database structure. But blockchain secures the data in a way that allows there to be multiple values that can be. I see in the chat that there is no presentation, so it's just me talking. So blockchain enables, in a way, for the information to be sent to be secured in a way where when I send the information, I no longer have access to that information. And that is why Bitcoin today has a valuation that people buy, sell, trade on the internet for. And I believe the latest price is $20,000, which is, of course, much higher than the initial price, which was nothing. So what that has meant and how that relates to smart cities and what we could do to build more sustainable infrastructure is we're able to now more efficiently transact value across a decentralized environment that the smart city then interacts with. So information of things is a key component to the smart city infrastructure, and for value to be interacted through information of things where all these devices that are written by different vendors can create, exchange value and reward each other in a ecosystem that requires blockchain technology, as it makes it much more easy to manage and control a ledger of value so that these debits and credits of tasks can be maintained. We could see one of the key examples of this is the file storage ecosystem. The first iteration of blockchain is that there is a process of securitizing this data through the hashing of the proof of work. And that's what's happened in Bitcoin. But the second iteration of data is a proof of stake and other proof mechanisms, which means that you're actually contributing something that is valued by the ecosystem in order for a reward to be provided. An early example of this would be Filecoin. So Filecoin uses the IPFS protocol to allow for file storage to be decentralized, where the value of your spare hardware and hard disk space is provided to a public network. And in providing that public network, the file storage space, you are rewarded with a file coin, which is a token for supporting the network. So this proof mechanism means that all of a sudden we're able to make money from the spare hardware that we have lying around the house. But in addition to that, what that also means is people who are consuming hardware disk space, they can have an alternate decentralized option. So instead of just paying the Amazon Web Services fees to store your data, there is an alternative decentralized option, which is you purchase these tokens from the open market, and of course pay in these tokens to reward those who provide this hardware space. The example of what we were able to achieve in China was deploy this kind of hardware solution to the decentralized ecosystem within the smart city. And the smart city implementation that we targeted is Hangzhou. So Hangzhou is more or less known as the tech capital of China, as it is also the head office of Alibaba. So what we've done was tokenized the renminbi, which is the national currency, and created an internal system for the parking management of the smart city. What that means is when you, in simple terms, go to pay for the parking, there is a QR code at the gate, which you simply scan and one click hit pay, and that transaction happens through what we called a micro app that is sitting inside Alipay and WeChat Pay, which are the two most popular payment mechanisms in China. So understanding of how dominant Alipay and WeChat Pay, they are the Visa and MasterCard equivalents of China, except they only do everything through the phone, through QR codes on the phone. So there are no plastic cards really in China. There is no real market penetration for that kind of technology. So what has happened is a very seamless process of tracking the usage of each of the parking slots and having that payment happen seamlessly through the boom gate. The referencing of each employee ID is also routed through the parking system, which means that for long-term employees who are not contractors, they, as soon as they arrive at the boom gate, the gate just opens without even asking for a form of verification and payment, because the nature of the license plate identification tied to the attendance and the occupancy of the parking space will allow for there to be a seamless transition of the usage of the space and the end of usage of the space to the boom gate opening. So what this has enabled is a opportunity as people who participate in work environments only utilize their parking space for a period of 12 and at most 14 hours. There is, of course, the underutilization of parking, which is for the remainder of hours, which could be up to 10 hours, 10 to 8 hours of the remainder of the day. And how do we give access to the underutilization of that parking inside the same office space facilities that, of course, house within the first 3 to 5 levels, a mall, for instance. So the flexibility and the sharing of that parking system can be more efficiently monitored, and what that allows is during the 8 to 10 hours of unused unused parking in that space can be offered to the secondary guests that may be visiting the mall to, for instance, do their shopping and their entertainment. So this shared economy of parking means that we're increasing utilization of the parking and also decreasing traffic flows as well. Because as you would know, if a parking spot is not found, the driver just keeps going around in loops, as we all have experienced when we do drive and travel from point A to point B. So a lot of idle time on roads causes additional traffic is simply due to there just not being enough parking when people travel from point A to point B.
Sam,
in addition to that, I want to highlight the opportunity of applying blockchain into the community planning and master planning of an urban environment. Because what we experience is just like in freight forwarding, which has now been heavily adopting blockchain technology to manage trade finance, to manage international trade. This process of, dozens of permits and legal agreements tied to the permitting process of land being on the blockchain makes this process much more efficient by processing this on the blockchain. So the fast tracking of these permits is a requirement, as we are expected to have 2.5 billion more urban people living in urban environments by 2050. So in other words, we have to bring 100 million people into an urban environment on average over the next 22 years. And this is only possible if we bring blockchain into the process, because efficient urbanization can bring about efficient GDP growth. Inefficient urbanization actually creates a net drag on GDP growth, because when you don't provide housing for the people, they'll still go to the cities, but they'll be living in slums. Slums ultimately are creating a net negative GDP outcome for a country, whereas proper urban master planning creates a net positive GDP growth, as people living in an urban environment are more productive and create more value than people who live in a rural environment from a GDP perspective. So if we look at the China strategy of lifting 700 million people out of poverty, it is by connecting the urban centers to each other, but building also these urban centers inside rural regions. So what that means is no longer are you traveling hundreds, or if not thousands of kilometers away from your hometown in order to have access to better prospects and opportunities. You are now traveling a mere 250 kilometers on average via bullet train in order to access the same economic activity. So that will mean that people can, instead of selling their rural properties in order to move to an urban environment, they can still stay put in their rural community access the networks and friendships and relationships that they have built over decades, if not generations, and have, of course, the access to a high-paying urban environment opportunity through just a 1-hour bullet train ride back and forth between their hometown as well as the urban environment. So
Sam, you hear me?
Yes.
Yeah, you can wrap it up as quickly as you can, just to keep the timing fair to everyone. Okay.
Not a problem.
All right.
So this accelerated methodology of urbanization is what we believe will grow GDP, and there is a lot that has been implemented in China that I think the rest of the world can learn from. Modular construction is also heavily used, as it allows for regions which have poor infrastructure for construction to have the construction being brought in and set up off the crane, and of course properties to and master plans to be built in a matter of weeks instead of years. So we believe that this is a great solution for low-cost housing, and of course uplifting people out of poverty. So I just want to sum up that the Blockchain Labs is the spearhead within the China Academy of Science to drive the discussion and the implementation of standards within value creation and exchange on blockchain for the China technology ecosystem. We've been doing standards and implementing standards all throughout China. China Academy of Science, being the largest research organization in the world, is here to continue sharing knowledge with the rest of the ecosystem to help them bring a blockchain into practice by first introducing the regulation and standards required to grow the adoption of this technology. So thank you, Doctor, and thank you for the other organizers. That concludes my talk.
Thank you so much, Sam. Really appreciate that. I remember when one of my 2 trips to China, I noticed that everybody was paying everything by this app, which I came to know that it was a WeChat. And that was first I came to know about the WeChat. And a lot of places even didn't accept the credit cards which were issued from outside of China. So it's, what you just mentioned, it just brought some memories back to me. So thank you so much. And we go to our next presenter. And Arjun, are you with us, Arjun?
Yes, Doctor, I'm very much here.
How are you today?
I'm very well, thank you. Trying to switch on the camera. I'm not sure if it's possible. Okay, camera has been enabled now. Great. Okay.
Sometimes a hammer will be helpful. Yeah.
Absolutely. I think it worked, and here we are. All right.
See, I told you that. You just say hammer, it will work. You don't even have to use it. So. Okay, you can start uploading, Arjun, your presentation. So Arjun is head of the technology and product manager at the Taka Solutions, and you will be talking about the paradigm of Industry 4.0. Okay, that's interesting. I don't know what that is, but I'm looking forward to learn it. And you're going to be talking about the UAE case studies. So you may proceed. So you have 15 minutes.
Yeah.
Time is
may I get the right to share my screen?
Okay, so we got our IT support in the background. Yalla ya shabab.
Hello, Doctor.
We need to Arjun needs help to upload his presentation.
Okay.
I can share the screen, right? I can share my presentation.
Yeah, give me seconds. Okay, please.
Okay, sure.
Arjun, you are in UAE, right?
Absolutely, yeah.
Very well, very well. Okay.
Okay, Arjun, you can go ahead.
Perfect.
Okay, so Arjun, you have 15 minutes, and I will try in between to disturb, which is not a nice thing to do. You know, I'm very bad in doing that. So sometimes I'm hesitating when to come in, when to click, but I will try to do that. See
I
if I
will try my best to keep it within 15 minutes itself.
appreciate that. Okay,
Right.
so you may.
All right.
You
I
may-
think let's get started. Good morning, everyone. My name is Arjun Upadhyay. I'm the head of technology at Taka Energy, and as mentioned by Dr. Rashid, we're going to be talking about Industry 4.0, the paradigm of Industry 4.0, and we're going to talk about a case study as well, which Taka has actually embarked on. Now, before we really get on to what is Industry 4.0, it's important for us to know, how did we get here? So there have been industrial revolutions before as well. And we start off with the first industrial revolution. This, in fact, occurred all the way back in the 18th century. And this was the introduction of mechanical production facilities. So this was a shift from humans, from tasks which were done by humans and animals to really be done by mechanical, by machines as a whole, which were powered by steam as well as water. We then transitioned over to the second industrial revolution. This occurred in the early 20th century. And in fact, this was the introduction of electrical production in facilities. So we transitioned from mechanical to more electronic way of things. And in fact, this was the introduction of assembly lines as well in order to boost productivity. Soon we transitioned to the third industrial revolution. This happened in the mid 20th century. And in fact, electronics advanced into more integrated circuits, transistors, so on and so forth. And this was the introduction of automation. So automation in sites, in plants, were then introduced in the third revolution. And we transitioned as well from less on analog to more on mechanical technology and digital sort of way of automating the plant. We then come across to the fourth industrial revolution, or also known as Industry 4.0. Now, Industry 4.0, in fact, was a vision which was evolved from an initiative to make the German manufacturing industry more competitive. This was, in fact, then taken across and, in fact, adopted globally as well. Industry 4.0 is nothing but it's a future state. In fact, we are living through it. It's a state which is actually maturing as we speak, of an industry characterized by merging the physical production and operation with the latest technologies which are actually out there. At the end of it, creating a more interconnected, holistic system for all systems to talk to each other. So in this state, in this phase, machines interact with each other. It's an interlinked system. As I said, it's a holistic one. And in fact, in this case, the key result of this is it not only would optimize the industry, but it will also and make it more efficient, but it will also end up making it more sustainable and efficient through cleaner production embedded in circular economy as well. Now, while the global world has actually been taking this forward, UAE as well has been driving this and really making it a very important part of the agenda as well. Operation 300 billion, which in fact strives to make the industrial sector almost 300 billion by 2031, has UAE Industry 4.0 as one of the key pillars as well. In fact, there's a fourth industrial revolution readiness index as well, which has been announced and is in the creation, which will assess how each industrial players in the industry here in UAE are adopting to technology and adopting Industry 4.0. Now, what really enables and what really drives Industry 4.0? There are multiple factors, but to kind of summarize that, in fact, the first one is technology upgradation and digitization. Now, as you may know, a lot of the edge devices, the cost of hardware has drastically reduced over the last few years. With this low-cost hardware enables us to actually make machines a bit more intelligent, add more sensors, add more intelligence to it. And with this comes, in fact, an influx of data. So technology upgradation, digitalization, low cost of hardware is one of the enablers for Industry 4.0. Connectivity is, in fact, a very, very important aspect as well. With connectivity, recently, we have the introduction of RFID, 5G advancements, which have actually been happening. Internet has actually become very fast and penetrated a lot of parts of the world, as well as alternate cellular technologies such as NB-IoT, LTE-M. All of these connectivity methods have actually enabled us to connect systems which previously could not ever connect or talk to each other to now start talking to each other. However remote they are, it is now as well accessible. Competitive edge. A lot of players in the market, all of the players are trying to actually see how you can actually have a competitive edge against each other. How do you go ahead and improve your accuracy? How do you improve reduce your operational costs, improve productivity, so on and so forth. And with this, in fact, comes augmenting your human decision making through intelligent algorithms such as AI and so on and so forth. So competitive edge as well is a key enabler and driving factor towards digitalization in Industry 4.0. Lastly, advancement in global sentiments. Over the last few years, there have been, in fact, a lot of there has been a change in fact, how people view sustainability as a whole. It has become, in fact, a key agenda for a lot of businesses. The UN has defined the Sustainable Development Goals, and a lot of countries have, in fact, pledged their support towards it as a whole. So this has become, in fact, an important factor as well. And all of these together are driving the industry towards digitalization. Some few key stats, in fact, over here. When surveyed, about 63% of the people in the industry, in fact, have said that it's the real-time process control. They see this as great value for them to actually embrace Industry 4.0. 47% of the entire group, in fact, said it's predictive maintenance. In fact, one of our esteemed colleagues, in fact, previously did speak about predictive maintenance. 47% of them, in fact, this is one of the key factors. And 41%, in fact, say that it's for energy savings, which is in fact a very good number and really a driving factor as well. We look at Industry 4.0 and we try to understand really what are the pillars and the frameworks around this. There are multiple pillars and frameworks, but we can summarize this again to 9 key pillars. The Industrial Internet of Things. Currently, few machines are currently fitted with sensors and interconnected, but with the Industrial Internet of Things, an even greater number of products will be able to talk to each other, to be connected with standard protocols, and this will decentralize analytics and decision making, which will then enable real-time responses and decision making as well, more like edge analytics. Big data and analytics. So there's a lot of data which is still untapped from the industrial world. Their analysis will actually optimize production quality, save energy, improve services as a whole. And again, over here, the goal is to allow real-time decision making. Now, cloud computing, in fact, is key to this whole thing. In the present scenario, cloud technology goes way beyond scalability, speed, cost efficiency, so on and so forth. In fact, it gives the foundation for the most advanced technologies like AI, ML, IoT. All of this resides on cloud computing, and it really is a great enabler for the rest of the pillars which we actually have. So the data that the power of Industry 4.0 cloud computing technologies reside actually is able to coordinate itself through cloud computing itself. Simulation and digital twins has also become very important. You're able to simulate and in fact create an exact digital twin of from machines to assets to entire facilities, and operators are now in fact able to simulate what could happen on their facility, on their plant flow by making certain changes before really implementing it as such, thereby improving the effectiveness, quality, as well as the time it would actually take to implement each of these. With so much data actually now flowing through, with so many different components talking to each other, all connected to the internet, cybersecurity becomes key, right? Those days of closed, unconnected operational management systems are days of the past. Everything is connected these days. Everything is talking to each other, which also introduces, unfortunately, to a lot of cybercrime threats. So cybersecurity is a key pillar in order to ensure all of the other pillars are secure, and in the Industry 4.0 as well is secure. Horizontal and vertical integration is also very critical. What do we mean by this? Vertical integration pretty much means integration from your sensor, from your edge device, all the way up to your cloud, analytics, so on and so forth. But horizontal integration is also important. As we said, Industry 4.0 is a holistic approach for the industrial sector, which means all of the other systems from procurement to supply chain to ERP systems to CRM, everything has to be connected from a horizontal standpoint as well as from a vertical standpoint as well. Additive manufacturing. Now, this is something which is obviously in its infancy, but a lot of organizations are now kind of embracing this, which is 3D printing for prototyping and unit production as well. With Industry 4.0, these technologies will be chosen for their very high performance in production for small batches and as well for customized products as well. Augmented reality is also something which is extremely exciting. Again, it's in its infancy, but a lot of industries are now finding a lot of useful use cases for this. This, in fact, really blurs the world between the virtual as well as the physical, and a lot of things which were previously only virtual and you have to access systems are now possible through augmented reality for operators of plants and so on and so forth. Autonomous robots at the very end is in fact what we are seeing already in a lot of industries, from automation, from logistics and so on and so forth. They will interact with one another safely with humans, which is now in fact a term which is coined as cobotics. This is in fact where robots will be helping operators to really perform their tasks. So as a whole, in fact, these 9 pillars, these digital technologies really do lead to increased automation, predictive maintenance, self-optimization of process improvements, and most importantly, in fact, a level of efficiency and responsiveness for all of us, in fact, which were previously not possible. It creates intelligence, introduces intelligence at different levels: field, control, process, management, enterprise, so on and so forth. TAQA, in fact, has been a pioneer in driving the energy agenda here in UAE. TAQA Energy specializes in really optimizing energy for specific facilities. This could be residential, commercial, the industrial sector, so on and so forth. And our services, in fact, lie in different places, from pre-design, in the analysis phase, the design phase, implementation, as well as managing. We have 3 key pillars. We finance projects as well, so we have very innovative financial models to support and drive, other companies, other industries as well, to embrace digitalization and Industry 4.0 as well. We have a key engineering sector internally, which actually is filled with a lot of energy engineers to actually deal with each of these services, from pre-design all the way to managing it. And the third one is technology, what we kind of coin as TAQA Unify. TAQA Unify is our flagship energy management platform, which enables and really handholds, in fact, every company, every industry from the very beginning all the way to reaching their goals for sustainability as well as higher optimization and so on and so forth. Our expertise ranges from energy auditing all the way to remote energy monitoring as well as controlling. And our capabilities, in fact, run from development, financing, construction, as well as operations management. As a whole, in fact, from when we started, we have saved about 90 million kilowatt hours, 23% of our energy savings across portfolio. We have more than 1,000+ facilities which have been audited by TAQA.
Arjun, you have 3 minutes to go.
Cool. All right. So TAQA Unify, in fact, as I mentioned, is our energy management platform, which in fact focuses on the different levels. From a field level, we connect to the machine sensors through open standards and open protocols. At the control level, we've got our PLCs and our control logic through the TAQA Sync driver. We then connect through the process level through SCADA PMS systems, operational level through TAQA Unify Op, and then enterprise level through TAQA Unify Analytics. In fact, we focus on the vertical integration as well as the horizontal integration via open APIs, and we really, in fact, ensure that we embody the design principles of Industry 4.0. Our steps, in fact, are very simple, and what we're trying to do with TAQA Unify is to simplify energy management and simplify the digital transformation. We try to make it easy and accessible to all. So we have certain steps which we actually follow. Step 1 is to really understand the current state of the facility through a utility bill management system which we have. Step 2 is to dive deeper to understand the energy distribution through real-time metering. Step 3 is real-time asset performance to go all the way down to the granular level for a specific asset. And then power up 3 key parts, which is energy, business, and operations, through multiple add-ons like the budgeting module, AI module, solar modules, and so on and so forth. A very quick run through over here. Our platform gives you a bird's eye view on the drill down all the way to dashboards. We offer a unified utility bill management system. We offer an energy analytics for measurement and verification of everything that's happening on a real-time basis. Real-time energy operational analysis as well for every asset which you actually have. Benchmarking, so we gamify the entire process and really ensure that you can compare your facilities against each other, and we provide an integrated energy platform as a whole. RSA, was in fact one of our key case studies, which we would like to talk about. And in fact, RSA, in fact, is a shipping and logistics company. We focused on the warehouses, and we in fact optimized and in fact reached them to a net zero state. This was a shared savings energy performance contract, which means that RSA had absolutely no upfront capital cost. Taka took care of everything. It was a 6-year duration, and multiple energy efficiency measures were implemented, from package unit controls all the way to the technology upgrades. With the entire setup, in fact, over here, we went through 3 phases. The design phase, which was the auditing of everything. We collected all of the data, measured the site, analyzed it, and reported and created a baseline. We then moved over to implementation, wherein we implemented detailed designs and specifications. We also took care of the procurement, project and implementation management, as well as commissioned all of the different energy efficiency measures which we actually suggested. We then reached the operations phase, wherein technology was then introduced into each and every different level. So we implemented an energy management system. Measurement and verification of the savings were conducted throughout. Energy analysis and forecasting using various different tools were conducted. And billing and reporting as well was all taken care of through Taka Unified itself. As a whole, this particular project, in fact, was a net zero project, which means that only 1% of the energy consumption was from the grid. The remaining 99%, in fact, of the energy consumption for RSA was then sourced from solar power. There were 7 EEMs which were implemented in total, 20% reduction in energy, and a lot of energy saved, which also from the start, I think from 2021 till then, almost 500,000 worth of dirhams savings for RSA. This was rated, in fact, and awarded as the Net Zero Project of the Year. And in fact, you know, it gives me great honor as well in saying that yesterday during the 2022 MENA Green Building Awards that actually happened, Taka Unify was awarded as the Green Building Product of the Year as well. So it really shows that Taka as a whole, in fact, we are really driving the agenda for Industry 4.0 in order to meet our sustainable development goals as well. With just RSA alone, you know, the savings which we were able to achieve, if we kind of try to quantify that, it's equivalent to greenhouse gas emissions from 198 passenger vehicles, for example, 39,846 trash bags, and so on and so forth. So we can only imagine if the entire industry really embraces Industry 4.0 and goes through this process, what kind of a social impact we can actually have on the world and on our surroundings. So to kind of conclude it, Industry 4.0 isn't just about investing in new technologies and tools to improve your manufacturing efficiency and so on and so forth. It's in fact a revolution. It's about revolutionizing the way your entire business in fact operates and grows today. So as a result of the support of smart machines that keep getting smarter as more and more data is made accessible, the industrial sector will become more efficient, will become more productive, and in the process, in fact, has the ability to become more sustainable and less wasteful as well. So with that, in fact, I'd like to conclude this. I'd like to thank you all for giving me this opportunity. Dr. Rashid, thanks a lot for the time, and I'll kind of hand it over back to you now.
Sure. I gave you 3-4 extra minutes. I don't know how much extra power you're going to give us in compensation of that. You know, but congratulations on your award yesterday. I saw and knew about it.
Thank you so much.
Well done, Arjun. Thank you so much. We will go to the next presenter, and we have Mariam Salman. And hello, Mariam. I think I was seeing you throughout the presentation. And hi, now I see you better. Okay, Mariam, so you may start uploading your presentation. Mariam is a consultant from Qamar Energy, and you will be talking about leading innovation in energy today, right, Mariam?
Yes, that is correct. I had actually asked the IT team to upload my slides for me because my Teams does not support, well, it does support it, but it freezes whenever I try to share my screen.
Okay, we have then Mohammed. Can you assist with uploading Mariam's document, please, presentation?
I will give the prompt for the slides as I speak through them.
Mariam, what are you talking to us today?
Give me minutes, okay?
Yeah, sure.
Second, yes, open.
Mariam, which city you are living in?
I'm in Dubai.
You're in Dubai, very well.
Yeah,
okay. Yeah. And Qamar Energy is a company that you are working with, right?
Yes, we are an energy consulting company. We sort of provide strategy, advisory, and commercial consulting across the energy spectrum. So from upstream to downstream and new energies and renewables.
That's great. How old is the company?
7 years.
7 years. That's great.
Yeah, it was started by Robin Mills. I'm not sure if you're familiar with him. He is sort of an energy expert in the region. He writes a lot for The National and has published a lot in other energy websites as well.
Okay, that's good to know.
Sorry, Mariam, what's the name of the presentation? Sorry.
It's called Green Uses for Hydrocarbons in the Sustainability Era.
Okay.
And Mariam, as part of your consultancy, what is it that you do in the projects? Which tasks you are responsible for?
So I'm the lead consultant at Qamar Energy, and I sort of specialize in providing advisory to businesses who are interested in investing in the region's new energy landscape. So I sort of specialize in CCUS and hydrogen and renewables, with also a niche focus on storage systems and batteries, so as to support these technologies in being an integrated whole for the region's uptake. This is
not the one, right?
This is the one. Thank you so much. Yes, you got the right.
Okay, so
I have a bit of a fever, so that's why my voice sounds funny. So apologies for that.
okay, that's good. We would have not noticed if you had not told us.
Okay.
Okay, Mariam, just you can tell me next.
Right.
Move your slides.
So you
Yes,
have
I'll give it.
You have 15 minutes, and then I'll try to nicely interrupt once you are very close to it. Okay,
I will try to stay within the time.
You may start now. Okay.
Thank you, Dr. Rashid.
Yeah.
So first of all, I'd just like to say that thank you to CEVC for organizing this very timely and important webinar that brings to light the opportunities and challenges that I feel the region faces in a decarbonized future context. I know my colleagues have already covered the more digital and technologically innovative side of things for the wider industry, but I hope my contribution can bring some light to where energy fits into this. So first slide, please. Next. Yeah, thank you. So, okay, when we talk of innovation in energy, my thinking was that how can the region continue pursuing hydrocarbons in a way that keeps them relevant in the sustainability era? There are a number of challenges that are pushing them to do this. And first of all, could you go back to the previous slide, please? First of all is peak oil demand. So, which we can see that it might already be on the way. This was once a distant prospect, which was considered to occur around the 1940s, but this has now already passed according to a number of international agencies. We know that this was caused mainly because of the coronavirus pandemic, which caused the largest decline in global oil use and energy-related emissions in 2020. And according to the IEA, this was the largest decline since World War II. We saw a massive drop in primary energy demand due to all of the lockdowns and such. And this drop of energy-related emissions, in which oil use emissions witnessed the largest decline, sort of fed into the Paris Agreement's ambitions, right? So CO2 emissions, they need to be netted out between 2044 and 2050, and overall GHG emissions between 2063 and 2068. Now, we can see in the left chart that the peak sort of passed in 2019 under the IEA's announced pledges scenario, sustainable development scenario, and the net zero scenario. And other agencies like BP and DNV have also suggested the same, that 2019 was the year we witnessed the highest demand for oil use, and this has now entered a steady decline. What is interesting to note is that even in business as usual scenarios, these have moved up the timeline for peak oil demand rather than having it later. So for example, in BP's business as usual scenario, it's now moved up to 2025. And I think DNV also moved it up to 2019 last year. What's important is that across all these scenarios, as you can see in the right chart, is that OPEC will remain the largest supplier of oil in the market. It's going to supply about 52% in 2050, which is 14% higher than its current share. Iraq, Iran, the GCC will provide most of the growth as new fields come online and production increases at existing fields. Still, oil and gas revenues will decline, obviously, for OPEC, despite the rising market share due to softening prices, lower demand, and other producers stopping or largely eliminating fossil fuel activity as decarbonization efforts ramp up. So oil prices under a net zero future will range from about $40 a barrel in 2030 to as low as $10 a barrel in 2050, according to WoodMac. And you can see on the left chart on the slide that this means that if only pledged climate goals are met. For example, if we look at the announced pledges scenario by the IEA, oil revenues will still just be a fraction of what they are in 2022, which is exorbitantly high because of record high prices. And rising decarbonization and electrification and softer prices, because obviously peak demand has passed and demand will continue declining, will force MENA energy companies to adopt diversification strategies to wean off their reliance on oil revenues faster than probably concrete climate action, although that will remain an important consideration. Still, I'd like to point out that revenues are not going to be zero at any point, even in aggressive net zero scenarios, because oil will continue to be used in non-emitting uses, like petrochemicals, or it could be used with CCUS, or it will be used in hard-to-abate sectors like aviation, where it could be offset. Next slide, please. So here we can see that funding for oil and gas is going to change. It's not going to be the same as it used to be. The region is facing the heat from a trifecta of challenges: the pressure to decarbonize, market volatilities, and peak demand. In this chart, you can see that institutional investment into energy assets over the last few years, institutional investments such as listed equities, shareholding, bonds purchase, etc., has shifted towards acquiring and refinancing assets with perceived reliable cash flows. So I think these would be renewables and energy infrastructure, or energy technologies that are integrated with low carbon options. So that could be CCUS or hydrogen, or even newer forms of power to X technologies. Funding for oil and gas will continue, but there will be a need for the sector to fund itself in newer and more innovative ways. So we know that there were a number of pipeline deals and privatization that has happened in the region recently. We saw the pipeline deals in Saudi Arabia and the UAE. There are bond issuances in Oman with the Energy Development Oman, and Bahrain is considering privatizing its oil and gas sector as well. And the proceeds from this privatization could go into funding for newer technologies, right? So it could go into CCUS or hydrogen, as I just mentioned, but it could also go into expanding petrochemicals or fertilizer operations like ammonia, which is an important carrier for hydrogen. Next slide, please. Yeah, thank you. So here I just wanted to point out the role of natural gas in innovating in energy. So natural gas is largely regarded as the cleanest fuel among traditional hydrocarbons. It can sort of support the region's low carbon future, although its role in the transition will require its ultimate decarbonization and the mitigating of methane emissions. Firstly, you can see that its global consumption is expected to peak much later than that of oils, so around 2040, although it does decline. Second, it can support the creation of the circular carbon economy by functioning as a background fuel for green technologies, so renewable power sources, or it can firm up the grid for blue hydrogen or CCUS, and even for green hydrogen in the way that it can firm up the renewable power used to power electrolyzers for producing green hydrogen. It can also help Middle East producers create a sort of a carbon space for their exports from cost-competitive unconventional natural gas resources, or increase flared gas capture in countries like Iraq, for example. This could take the form of carbon-neutral gas or carbon-neutral LNG, which has the emissions already offset, or at least an emissions transparency mechanism involved, which requires the suppliers to report their related emissions per cargo. Gas can replace crude for generation. It can replace heavy fuel oil for desalination. It can expand the petrochemicals industry, and in this way, it can boost diversification. Demand for gas is expected to remain strong in the Middle East. It's going to be a strong center for gas consumption till at least 2035, before the rate of growth enters a slowdown, mainly because of subsidy phase out, better dues collection, higher efficiency, higher uptake of.
Did we lose her?
Mariam, you're still there with us?
think we lost her.
We'll just wait. I'm sure she will try to log in back again. We will just give wait for a while until Mariam comes back. What is interesting here is that we all have heard about the hydrogen, right? How the hydrogen is kicking in as an alternative source of the fuel, maybe, or now we have the green hydrogen and the blue hydrogen. Yeah. Anybody has any thought about? Okay, Mariam is back. Mariam, you're back. Your microphone is now muted. Your microphone is muted, Mariam.
Hello, can you hear me now?
Okay, okay, we are just waiting for you.
I don't know what happened there. Apologies for that.
We knew you're gonna come back, so we were waiting.
Thank you. Okay. Anyway, just to conclude with this slide then. So as I was saying, that demand for gas in the Middle East is expected to remain strong till 2035, after which it will sort of enter a slowdown, but it will result in a surplus that can offer several opportunities. But the thought behind this is, what is the surplus going to be used for? Is it going to go into new light industry or industries like hydrogen that will require gas either to produce blue hydrogen or to firm up renewables? Or is it going to go into the coupling with CCUS to eliminate nearly all CO2 emissions that can support the creation of these new lighter industries? Surplus can also support electric vehicles, electricity demand, and can offer the potential for extra regional electricity exports. Next slide, please. So when we talk about innovation in energy for the region in a low carbon future, obviously that means a lot of CCUS. A renewables-led carbon neutral future cannot materialize without aggressive movement on capturing and utilizing and storing existing or near-term CO2 emissions, as the majority of the global energy system is still fossil fuel based and it cannot be retrofitted to function on low carbon technologies overnight. Now, as I mentioned before, renewables require flexible backup to firm up grids to reduce their intermittency, but heavy industry, for example, needs reducing agents and high temperature heat, which can be provided by gas or hydrogen, but because you're using them, that will require interim solutions like CCUS. And there are already several options existing for mitigating carbon dioxide from fossil fuels. They can be embedded in petrochemicals to produce long-lived products like plastics. Through CCUS, it can be used for EOR, which a lot of national oil companies are already doing, or it can be stored permanently. Bioenergy, which is also another interesting topic in the innovation for energy, can be coupled with CCUS to extract bioenergy from biomass and capture the resultant CO2 for storage. The left chart shows the technical potential and the right chart shows you the storage space that the GCC has. It has agreeable geology and terrain for storage. There is high public acceptance of CCUS. The region has relevant petroleum-related skills and a limited number of large point emitters, which are strategically located in close proximity to end-use sectors and off-takers, which is very beneficial for creating a circular model around them. Next slide, please. Exactly. So you can see here that this CCUS potential can encourage the development of a combined CO2 and or hydrogen clusters. Now, this map is from a report we did on behalf of ADNOC and the Ministry of Energy and Infrastructure called the UAE's role in the global hydrogen economy. And it's showing you here that in the UAE, existing natural gas infrastructure can be utilized for processing, transportation, and storage of CO2 or hydrogen, which can support the establishment of combined hubs in key industrial and port cities. So you'll see along the belt, we have Dubai, Sharjah, Ras Al Khaimah, that industrial belt, and then we have Abu Dhabi. So existing LNG export and import terminals here can be modified or retrofitted to support international trade in hydrogen with key markets, while gas pipelines and salt domes can support transportation and storage. This could enable the region to be a center for CCUS for its own needs, or it could import or re-import CO2 from its hydrocarbon exports, thereby contributing to a circular carbon economy. Next slide, please.
Mariam, you have 3 minutes, please.
Okay.
Thank you.
Sounds good. So blue hydrogen, of course, becomes important then to continue using hydrocarbons. Now, low carbon hydrogen represents a potential route to decarbonize domestic industry and to create new export streams, whether that's hydrogen directly or hydrogen derived industrial materials such as ammonia, plastics, synthetic fuels, or steel. And why blue hydrogen is more important in the interim towards green hydrogen is because the technical efficiency and capacity factor of green hydrogen production still needs to be improved. So, and the costs of electrolyzers need to come down. So natural gas coupled with CCUS will be the main form of production for low carbon hydrogen until then. And you can see that MENA is very competitive. It beats every other region on costs for blue hydrogen. Even the inclusion of a CCUS in the natural gas costs for MENA keeps it very competitive. It's one of the lowest in the world. It's far superior to hydrogen that could be produced in Europe or in East Asia. Of course, Russia is out of the picture. And blue hydrogen alone could annually unlock revenues of 40 billion for a 10% market share and up to 100 billion for a 30% market share, which is very material when you compare it to the revenues that they would earn under a net zero future, as we saw in the earlier slide. Next slide, please. I quickly wanted to touch on biofuels or bioenergy and the role it might have in the Middle East region. So this chart on the left is from the IEA under its very aggressive net zero by 2050 scenario. And of course, currently there are hundreds of millions of people in the world relying on traditional biomass. So this scenario assumes that traditional biomass will have to be removed from the world's energy system by 2030 so that we are on the pathway to a 1.5 degrees Celsius temperature limit. But that's not really believable. Regardless, biomass has a really big role. Even in this view, you can see it's 100 exajoules by 2050, whereas current oil consumption is about 184. So that's more than half of it, making it critical. It can be a substitute in areas currently served by fossil fuels, so natural gas heating, industrial heat, high temperature heat, etc. Probably BECCS, which I just mentioned, is the capture of CO2 from bioenergy from biomass. Now, the Middle East region itself doesn't have much biofeedstock, probably due to its geography and temperature, so it will prefer to rely on hydrogen and ammonia or other synthetic fuels, such as methanol, which is a major one, for decarbonization. We know there is a lot of interest in green methanol for shipping. Maersk has already gone down that route, and there are other shipping companies showing interest. Synthetic kerosene, which is very niche and expensive, but it could also be an alternative. So these agencies, they have a big role for biomass, but there are several concerns of how it's going to be managed, right? So globally on land use, biodiversity, its impacts on water and the emissions like nitrous oxide, how it impacts the carbon cycle, etc. I'd just like to say that this target that is set in the net zero scenario is really high, but that level might not entirely be sustainable by 2030. Next slide, please.
Mariam, you can please wrap it up right now?
Yes, this is my last slide. So here I just wanted to show what the Middle East energy companies are doing to sort of lead this innovation in their strategies for a decarbonized future. You can see that this table shows some of the companies that have strategy 1, which is, or I could call it strategy 0, which is a limited transformation, where they do not really have decarbonization plans in their in their strategies. So this would probably be the Russian oil companies, or it could be Iraq, Libya, or Algeria. They really do not consider hydrogen or CCUS. The other part of this is those companies that are including actively new energies into an overall hydrocarbon portfolio. So we have the Chevrons, we have the Aramcos, etc. Then there is, of course, an increased focus on internationalization and venturing into more downstream activities. But this is a mix between Middle East companies and international companies. This is sort of to secure future offtake markets. Strategy 2, or plan transformation, I would say that probably ADNOC is the one that fits closest to it. It's sort of following its peers in Europe in this regard, having bought a stake in Masdar. So it's going down that green route faster than its other peers. And the last strategy, of course, is investing through sovereign wealth funds, which this obviously initiates new low carbon in the region through CCUS, nuclear, renewables, and hydrogen. Last slide, please.
We are really beyond the time, so.
That's it. Thank you.
Okay, great.
Yeah.
Thank you so much, Mariam.
No,
So
that's
if we
good.
gave you extra time, we'll give you some of our carbon dioxide so you can like treat do something about it.
No, I dropped off in the middle for some reason.
I know. We actually considered that. Okay, great. So thank you. We can debate this for a whole day, but we will go to the next presentation. And Engineer Mohammed Al-Kaf. Mohammed, you are with us?
Yes, I'm here. Can you hear me?
Hello, Mohammed. Gary, we can hear you and see you as well. How are you today?
Great.
Good, good. So, Mr. Mohammed, you can start uploading your presentation. So, Engineer Mohammed is the CEO of MCPM MENA Holding and UI Ventures. And you will be talking today about sustainable agri-tech in the Arab region. Is that right, Mohammed?
Yes, true, Doctor.
So the timing has changed now. Instead of 20 minutes, it's 15 minutes. And so if we can please like reframe it, the only thing you can do is speed up, right? So reframe it in 15 minutes. And I will try to give you some sort of nice reminder way before you get to the end of the 15 minutes.
Okay. No worries. I'll try my best to make it very, very short. Can you see my screen, please?
Not yet. I cannot see your screen sharing yet.
Yeah, I'm trying. I just put it and upload it. Maybe it just take a little bit time, but I'll try to. Yeah, you can see it now.
Yes. Go ahead. It's clear. It's clear, Mr. Mohammed.
I cannot hear you.
It's clear. Yeah, the presentation is appeared nicely.
Is it okay? I cannot see it. You guys, everyone else can see it?
Yes, we can.
Can see it? Okay. Okay. If then you can start, I will solve it myself.
Okay. So if everybody can see the presentation, then we can start. So first of all, I would like to thank the Clean Energy Business Council and Dr. Khalid, and also the Environment Center for Arab Towns and Mr. Khalid Badri Al-Awadi. They are always doing a great effort in spreading the awareness for technology and sustainability and preaching that for all the leaders in the region. So today we're going to talk a little bit about some technologies and how we can help, especially in the agriculture, how we can have sustainable agriculture, how we can have sustainable demand and supply chain. And then also we'll talk a little bit on how we can use the technology and artificial intelligence for the food security and some of the practices. All what we are going to talk about today are technology and projects that are existed in reality, and it is implemented in many countries. So it is not just something theoretical or some concepts we're talking about. All what we will see is already happening somewhere in the world, and we're already running that project. So let's have a look on how artificial intelligence and technology can help us when it comes to the agriculture. First of all, we need to look at the whole ecosystem, how we can build a consistent ecosystem that really helps in crop yield prediction and price forecasting. It can help also in intelligence spraying, in predictive insights, agriculture robots and how it can be used, and crop and soil monitoring, and then disease diagnosis. This is the whole ecosystem that technology can help with. But when we talk about the agriculture, one of the most important things that comes to our minds that how we can have a very reliable and strong communication, because the locations of most of the farms are not in the city. So usually there is a communication problems, and then if we will use a data center or we'll set up servers where we can put the algorithms and the AI and start working on it, it cannot be always there in every farm, and it will increase the cost, and also the infrastructure might not support it. So to have everything connected when we use artificial intelligence, Internet of Things, and all the sensors there, and then we send it to the algorithm for analysis and get back the results, we need a very good way of communication. After certain time of research and development and studies, Microsoft reached to a results where there is a little bit of the satellite band where we use everywhere for the TV channels. A little bit of that band is not actually utilized, and that's enough for us to get the information sent through it to the cloud or to the main data center, and then to start using the artificial intelligence. So we started using that band that was not utilized in the past, and it helps us to send this. The most and the good things about the satellite that it covers the whole Earth. So the whole Earth, also the communication problems is totally resolved here. And on the other hand, we are using also the satellite photos where we focus, like when we extract the data from the farms, we are not only using Internet of Things or sensors. Yes, of course, that's important, and we take very important parameters through it, but also we validate that information using the satellites and how it captures the pictures of the plants and how it gives information on the growth and how it looks like. So combining this all together, it gives us solid information that we can take it to the artificial intelligence algorithm and then get the right recommendation and the right information. So with that, we will have remote monitoring without a need to go ourselves physically to the farms. One of the most important things also is to know when to fertilize the plants. Let's say I mean, in the past we were saying it's not easy to talk to the plants, it's not easy to talk to the trees, but with the technology now we can talk to them. When we deploy a certain type of sensors, it tells us exactly what's the best time to do the fertilization. And then when we know this, we will be able to get the best product and the best yield. So this all information combines together to give us to be taken to the web servers, and then we take also information from the sensors to monitor and to get the climate data and information about the plants itself. And then we will have a control using controllers and PLC where we have automated based irrigations, which saves a lot of water. This all technology combines together. It helped in the reality to increase the core by 5%, to decrease using and consuming water by 30%, and then to have a real-time monitoring. So when there is any pandemic or any challenges happening, we eliminate the need of having a lot of manpower on ground. So I'll just, because of the limitation of time, I'll try to jump to the other practices and combine it together. So having been, we spoke about the agriculture and the technology and how we have a very good yield and core, but let's combine this with the supply chain and the demand, because always we have a very nice production, a very nice products, and but the challenge is that how we take this to the consumers, how we always be on the demand level. We don't go under supply or oversupply. One of the challenges that the people face in the world is that 30% of the production of the food and medicines is really going to waste, because it faces challenges on the delivery, on the supply chain, on how we take it to the end customers. And according to a report published by Pfizer, 30% it just got expired or damaged or waste before it reached to the end user. So how can we solve this problem, and how technology can help us to solve this problem? Always we can say the data is the key. So when we have the data, we really can feed it to the artificial intelligence and get the right information. So where are the data that's related to the demand? Always it's there where the consumer is buying the goods. When we look at the big hyper markets and the big pharmacy chains, they have always their data stored in their database. And from that data, when we take it and feed it to the artificial intelligence, we can analyze the consumer behavior, and we can slot it to the yearly and let's say different part of the year and different quarters. So we know, for example, when it is summer, the demand will increase on a certain part. When it is winter, the demand will increase on a certain part. And then we connect this with the big stores in the world, and then we connect it with the supply chain, so we know what to order and which part of the year. And then having this all connected to artificial intelligence, we have a very accurate forecasting. And not only accurate forecasting, but artificial intelligence will help us to get the best sources and the fast delivery one. So having this information feed it to the AI and machine learning, it really helps to get accurate information about the demand and about the supply. Now, we spoke about the agriculture and how we apply the technology there. We spoke also about the demand and how we put the technology related to the demand and supply chain and connect it with the production and farms and yields, and then how to deliver it to not go to over demand or oversupply or undersupply. But there's always a question comes here when it's related to food and production and delivering the food to the end users. Can we have a monitoring? Can the end user monitor this food that comes from the day one until it arrives home? We have here example on how we can monitor the milk, for example, when it is before it's being produced until it arrives at our home. So when we look at the whole ecosystem of this production, it started from the animals, where animals can be also attached to sensors and Internet of Things that gives us information about the animal's health. And then it goes to the factory and production, where in every stages, this all information will be stored in a smart QR code that's connected to the GPS. And then it goes to the supply chain, where it goes to the cars or the trucks that takes it from a place to place. And here the sensors and technology will store all information, storing information, temperature, humidity, all related things in a smart QR codes that's attached to this product. And then it goes to the international logistics, it arrives to a certain country, it goes to the inventory, and all this information is stored. And that's, I'm not talking about the future, it is happening in some countries and some projects that we did, where the consumer can just scan a QR code and get all the information, for example, about the cup of milk that he's drinking from the animal until it arrives to his home, and he drink it and he makes sure he's getting a very healthy product. And last vertical I want to talk about is just example of a very smart farming and structure that's happening in Abu Dhabi, where this farm, it has something called aquaponic. What is aquaponic? It's an environment where we mix the fish farming and then the agriculture farming. So we don't need the soil here. We have just the water, and under the water there are a lot of fish, and then above the water there is the agriculture. So the fish under the water will be feeding with special type of foods that produce the ammonia, and then we inject also the beneficial bacteria to convert the ammonia into nutrients, where the plants can take it and absorb it, and it can grow. And then the water itself, it's being recycled. So in this environment, we're getting benefit of many things. We are doing the fish, we are doing the farming, we are recycling the water in one environment with a very cost-effective model, and that gives us a lot of variety of products with quality. And I mean, it can be delivered with a very low cost. So we talk here about technology, about cost efficiency, about how to produce a different type of products in a very smart way. And this is, we were in the past saying that might be a future of farming, but now it is a reality happening in some of the smart fields in Abu Dhabi. These are some of the pictures where you can have a look and see how it is happening. And what we can get from this in future also is that this can be part of tourism. In many countries, I've seen in South Asia that there are a lot of factories where people go and visiting and check all the production way, how it is happening in a very smart way. So there's something called sustainability and manufacturing tourism, which we are encouraging it to happen in the country, but by having the smart technology presented in a very elegant way. So people can come and check and learn and copy this model and support the sustainability in their different areas. So I hope I could deliver part of the ideas and part of what we are doing and how we connect the technology with all of this. And due to the limitation of the time, I cannot go more deeply here. If we have some little more time, maybe if there are some questions, I'll be more than happy. If the time is done, then I will be very thankful for your patient listening, and I hope I could provide some useful information to you.
Engineer Mohammed, thank you so much, especially for being exactly on time. We will have the Q&A session at the end of everyone's presentation. So not in the middle, but at the end of the presentation. So thanks again. With that, we will proceed immediately. And I can hear a lot of hammering and
I'm sorry, there is construction happening around.
Are you feeding the fish here from the water over there? Or the fish like bumping the head, giving some more food? What's happening over there?
I'm very sorry for this noise. It's actually my neighbors. So
that really gives us the feeling of the work environment you are in. Thank you so much. So we will proceed to Avijit, sir. Avijit, I can see you already on the screen here, and your mic is muted. Can you unmute?
Yeah.
Okay, there you go. Welcome.
Can you able to hear me, Mr. Rashid?
We can hear you, we can see you, and thanks for being with us. So you may start uploading the presentation. So Avijit is from Technology Business Consultant, Rebus Novus, right?
Yep.
And you
hi, Dr. Rashid. Thank you so very much.
Sure. Digitalization of the grid, unlocking opportunities in the Arab region, right?
Just give me a moment.
Sure. So as you get ready, just a reminder that you have 15 minutes, 15 only. The time gets from
so
20.
I will not delve much deeper into everything. So you can able to hear me, right?
It is breaking from my side. I can hear you breaking, but yeah. So you have 15 minutes. Try to fit in within 15 minutes, and I'll try to give you a reminder way beyond that. With all that, you may start.
Yeah. Thank you, Doctor, for giving us the opportunity to present, and a special thanks, of course, to the organization authority, okay, for organizing such an event. Okay, so yeah, I mean, talking about the digitization of the grid, why there is a need for it, and what exactly is driving us towards getting into the digitization for the grid. So before me, there are a lot many speakers who have actually spoken more towards what are the benefits which we can potentially able to leverage by adapting to all kinds of advanced features from IoT, IIoTs, artificial intelligence. Okay, so I'm not going to get much deeper into those, but how best we can able to achieve those by incorporating those kind of things inside the grid. Okay, and what are the benefits it is going to give it to us? Okay, so I mean, if we get into the introduction part of it a bit, okay, so if you look into the power industry in general, some trends reflects across the entire region, while others are more specific towards the socio-economic status of that particular country. So these trends includes basically, for example, for certain countries in the overall Middle East region, their focus could potentially be more towards the accessibility and the availability of the energy to all customers. For some, it is more focused towards the facilitating the growing demands. And for the other areas, like it's more about the objective towards achieving the carbon neutral milestones which they have set for a longer terms, or in a shorter duration in time. So in terms of achieving all these things, okay, there is one of the key factors which we always gets a big amount of impact, that is with respect to the power quality. So while we keep on increasing our overall demand, it actually impacts the overall power quality part of it. I'm going to come to it afterwards. So what are the key challenges which we are potentially having in the existing system? So if you talk about the existing system, or the old system which we were having, it constitutes of like very large power plants, couple of large power plants which are mostly centralized, and from there we have to like transmit energy from one particular place to another. So the power plant can potentially be in the middle of a city, or maybe a bit of the outskirts of a city. And if we have to provide a small community which are like way far away, we need to actually invest a lot of money for the transmissions and all these kind of things. So the key challenges which we experience in the transmission is the transmission loss. Okay. And it is mostly unidirectional in nature. So unidirectional in a sense, if we talk about like, okay, we ask the customer what is their peak load. Basically, depending on their peak load, we balance the overall, or we generate the overall generation capacity of an overall system. So the peak load defines basically the generation, transmission, and the distribution capacity of an electricity system. And also it serves a very important design metrics for the current and the future electricity infrastructure. As the electricity load changes throughout the day and the year, the electricity system, including the generation, transmission, and the distribution, must be able to deliver the maximum load at all time. So in reality, what happens, okay, is that the infrastructure which are built basically to provide the maximum load, okay, it's mostly get underutilized during the non-peak times. So in order to address that particular shortcomings, okay, and also the loss which are being incurred during the transmission, and inability basically to manage the peak load sometimes, and the lack of interoperability. Lack of interoperability means basically we can also have smaller power generation units which can also contribute, but then connecting those things to basically the grid, it sometimes add up to a lot of other challenges contributing to the power factor issues. Okay. And also the infrastructure mostly are quite old, and interoperability between the old and the new infrastructures are also add up to a lot of challenges. We do not have actually the visibility towards the old infrastructure that when it can potentially fail. Okay, and the integration of the powers, as we said, like with the renewable resources, wherein like in the Middle East region, I would say we have the potential of having enormous solar energy. So how best we can able to leverage that and also not disrupt the existing overall system. So that is when we need to basically get into the digitization of the overall system. So if you look into the the systems which are actually getting adopted in the future, in the coming future, or now slowly and gradually, even the entire, all the countries started actually delving themselves and adapting themselves towards this transformation. That is basically the distributed power system, wherein we can have multiple sources. Like it need not have to be only one large power plant. Rather, we can have numerous small power plants which can be actually contributing the power to those regions. And then whatever the excess energy it can generate, it can able to, provide it back to the other regions as well. So that's what it is. It's called basically the decentralized approach. And as because there are like a lot of decentralized approach, so the necessity for carrying the heavier investment with respect to the transmission side largely get decreased. And by doing this way, we can also adapt to basically bidirectional nature of, and we can actually leverage the bidirectional nature from customers to the producers. So basically the customers can also become a key contributor as a producers. So we will come to that afterwards. So what we call it is basically the 3D model for the grid transformation. Just sorry. Okay, so 3D model of the grid transformation, it basically constitutes 3 key elements. One is the decentralization part. So because we discussed, as we discussed about earlier that, okay, it used to be only one or multiple power stations where from we have to integrate everything to substations, and then from there we need to, lay very, high tension cables from one particular place to the very remote places. So that particular things can potentially largely be optimized. We can still have those infrastructure, and wherein in the remote places we can have another power stations which can basically cater to the basic needs of that particular region. Okay, for example, by means of solar PV or the distributed storage or the microgrids as an example. And this is basically called the decentralization part. And associated with the decentralization, I would say there are also the possibility for us to incorporate the digitization. So we can ideally digitize each and every assets, whether it is the existing and all the new, power grids, which are actually going to come, and also the microgrids and each and everything. Each and every elements of these can actually be digitized and have a real-time communication with the centralized grid. And by adapting these two, we can also adhere to basically the decarbonization or the critical long-term carbon footprint goals for a particular nation. So I will just give it an overview with respect to the capturing the flexibility of the distributed generation. So it constitutes basically the operation perspective, the hardware and the software associated in leveraging all the digitization part of it. And also it has to have a certain frameworks which must support the overall ecosystem of the digitization and the decentralization. So the hardwares, as we can see, like from the existing one, we can actually have the smart meters connected to each and every outputs and each and every, the generation, as well as the consumer side. The remote control and the automation systems can actually provide a lot of, data and a lot of, resources for us to kind of understand that what exactly are the data which we can actually able to, leverage to. And if we talk about, yes, the hardwares, the smart inverters, okay, bidirectional smart meters, okay. So we are not going to talk much about this as because the time is, very limited here. So we are going to talk more about with respect to the understanding the impact of the digitization on the electricity sector and its assets. Okay, so while we are going to actually do the digitization in the power sector, it has basically 2 segments. One is the data and the analytics, and the another one is with respect to the connectivity part. So connectivity constitutes actually 2 elements. One is the connectivity associated with the power side, and also the connectivity which constitutes also with the data side. So all this data which we are actually accumulating from the smart meters, from IIoT devices, from condition monitoring devices, from each and every individual devices, okay, these data we can able to make sense out of those data. So the data and the analytics provides basically the predictive maintenance and the planning and the operational changes we can able to adapt to it. So if we talk in general, so I have actually categorized this into the 3 segments. Let's say the green indicates basically the financial benefits for the asset owners. Okay, so those who are basically operating the assets, the grids and everything. The red associated with the system benefits and the consumer benefits, and the blue it's more towards the global and the environmental impact. As we talked about the overall 3 segments, so we are talking about these, 3D steps of of implementation. So if we look here, okay, by analyzing the data and having the functionality earlier, I think, the gentleman from the Taka Solutions and from the MCPM, Mr. Samir, they have already explained about the benefits of artificial intelligence and also the IIoT and Industry 4.0 infrastructure. By leveraging those artificial intelligence and the overall infrastructure, we can actually reduce the overall OEM cost, okay, by reducing the overall investment needs, reducing the fuel consumption and the cost, and the reduced CO2 emissions. And it also reduced unplanned outrage. So earlier, what used to happen is all of a sudden, if there is a sudden increase in demands from all of a sudden, one particular plant has a huge necessity for the powers. And if you look into the current scenarios, I mean, our requirements are also very dynamic. Incorporating.
You have 2 minutes to go.
Oh, is it okay? I'm really sorry. Okay, so I mean, looking into the, so I will probably skip this particular part and get into the transformations on the connectivity side. So if you look into the trend, so earlier we used to have basically the energy silos, which are non-flexible in nature, mostly centralized, low connectivities and all these things. And we are driving towards the high connectivity areas and all these things. Okay. And the future of energy systems will constitute basically the 3 layers. One is the physical layer, wherein like the electricity grids with the meters and all these things. Then the digital layer, which will have actually the digital hardware, metering, and the controls, and the energy data analysis, and the digital twin network, and all these things. And the ultimate layer, there will be the service layers, wherein the consumer can also leverage from getting the advantages of using less amount of energy. And thereby they can also, if they have the cogeneration unit, they can also able to contribute back to the generation part. And the overall system can actually harness the advantages of the digitization. Okay, so the data flow, usually it goes from the data collection to the smart meters, grid sensors, and the IoT data to the data processing side. If we talk about like the reduction of the non-metered energy, okay, better grid observability, digital twin of distribution network, forecasting of consumptions and the generation, looking into the amount of consumptions which could potentially happen and looking into the trend, as because we will be having historians and the predictability through AIs, we can able to forecast much prominently that, okay, what could potentially be the need for my consumption. And basically based on the need of my consumptions, I can actually able to leverage the utilization of my generations as well. So basically what it helps is it enhances the operation and the investment perspective from both the consumers as well as the operators. So the less outrage throughout the predictive maintenance, okay, the better targeted investments, okay, flexible, allowed and the delayed investments, and flexibility towards basically allowed and delayed investments, and the reduced technical and non-technical losses. And the reduce.
You can wrap it up, please. You are done with the timing, please.
Okay, so a smart grids usually looks like this. Okay, so it has basically the vision of the future, wherein like each and every individual ones are interconnected with each other. Okay, and wherein we can able to kind of harness the waste to heat recovery systems to generate the power, and also takes variable load from the grid depending on the requirement. Okay, thank you, doctor, for
Right, thank you so much, and apologies for like squeezing you within the 15 minutes.
It's okay, sir.
But very interesting. So we have 2 more presenters and presentations, and we will proceed immediately to Bokar, if I'm saying that right. Bokar Alpha, did I say right? Bokar, are you with us? Or both are, let me just check.
Yes, I am with you and trying to activate my camera.
Okay, did I say the name right? Is it Bokar or Bosar?
Bokar.
Bokar, how are you today?
I'm very good. If I find a way to activate my camera, just bear with me 1 second.
As you do that, so I will introduce you. Bokar is the CEO of Samina Telecommunications Council, and he will be talking about the digital solutions for the environment in the Arab region. And He's trying
Yes.
to. Okay. Hey, there you go. Okay. Nice to see you.
Good to see you.
Where are you talking to us from?
I am calling you from Dubai. I'm in Dubai.
Oh, you're from Dubai. Okay.
Yes, I am based in Dubai, and I would kindly ask our facilitator to project my first slide.
Right. Okay. So since we get that done, so we have 15 minutes. I know that the time was changed from 20 to 15.
I'll promise to make it in 14 minutes.
Okay. And then if not, I will remind you in the last 1 minute. You may start when you're ready, Bakar.
Yeah, I'm ready to start. I would like to have the first slide on the screen.
Okay.
Yes, that one.
Okay.
Excellent. So thank you very much, Dr. Rashid, and good morning to all of you. And allow me to start by saying it's a great privilege to be in your esteemed company. And I would like to take this opportunity to congratulate the organizer and stakeholders in bringing about this sustainability-driven discourse. Ladies and gentlemen, I would like to start by giving a context to our discussion. And I would like to say we are today at a time when economic growth and sustainability across every function of business and life have emerged. Let's go first to the slide before. Yes, let's stay there. I just wanted to give the context. And I was saying that every function of our business and life have emerged among the greatest focal areas, and it is important to see how digital solutions and ICT infrastructure can help our region in achieving our collective goal of realizing a green, low carbon and high productivity based economic transformation, which of course should be sustainable, human-centric and digitally powered, and which should, let's say, aptly attend to the needs of our future generation to come. Regardless of the field of collaboration and deliberation, our collective efforts should aim to yield fulfilling outcomes connected to the success of the public sector as they are for the success and sustainability of the private sector, the environment, and we are in the Arab region, the Arab society at large. So I would like to say, colleagues, 2 years of global lockdowns and pandemic restrictions have now accelerated the urgency to focus on sustainability as a key principle of socio-economic recovery and transformation around the world, including our region. And interestingly enough, such urgency has placed the fundamental role of ICT and those who build and operate ICT infrastructure. You understand I'm referring to the Etisalat, the telecom operators at large, and bringing technological innovation to us in the form of new services and applications at the forefront of revival, digital transformation, and future development. Now, in today's privileged opportunity to speak to you, I would like to take you first. Let's have a look at the region together in terms of how it has transformed, how new technologies are helping set new aspirations, and this will help set the context of why and how ICT is enabling new possibilities in the private and public sectors, and also in our strides toward materializing a sustainable future. Dr. Rashid was asking me where I'm calling from. I'm in the UAE, so the case of the UAE will be assessed. What development we see in other regions, And finally, what our outlook is of the future in terms of sustainability, aspiration, and dialogue, and how we can digitalize and innovate the energy sector and the work required to achieve our goals. I will also finally attempt to raise the sustainability context and argument beyond urban development in the age of digital economy toward tackling difficult and interconnected challenges in the age of the space economy, and I'm referring to the space segment. Now, let's get started by seeing the second slide, please. Thank you. Ladies and gentlemen, in the Arab region, economic diversification and digital transformation are two major driving forces catalyzed by strong national transformation visions. On the technology front, popularity of high-speed data services, especially 5G services, are on the rise. And a foundation is being created for 5G Advanced. For those who knows the ICT, we call it 5.5G. This is a direction, it's a direct reflection of the focus this region has placed on digitization and on the alignment of private sector and national priorities that some countries of the Arab region have conducted ahead of time in order to reap the benefits of wisely defined ICT visions, foresightedness, and the political will to transform policy into measurable actions. And I can tell you, and I'm a witness, that the UAE is an outstanding example of having implemented such an approach ahead of time. Next slide, please. Dr. Rashid was referring at the beginning, introducing me. I represent the private sector industry at large, and I can share my observation with you that the telecom or ICT private sector, even as itself undergoes evolution, it is busy facilitating remote working, which has dramatically improved the level of happiness, motivation, and productivity here in the UAE by enabling online education, providing new data and voice benefits, promoting digital channels and e-commerce, bringing cloud and AI-based capabilities that benefit citizens and enable smart city planning and transforming core and emerging economic sectors. Heavy investment, for instance, in 5G are taking place to make all of this happen. However, where on one hand, the region is digitally transforming and economic diversification is solidifying, on the other hand, the region's population growth, economic activity, high consumption rates, and the recent uptake of ICTs have placed altogether new pressure on the environment, which is unsustainable if not acted upon in a smart and sustainable way. Let's have a look on the next slide, please. ICT enabling power has been well established by now, especially following the effect and impact we all observed during the last 2 years. And ICT-enabled solutions are driving impact across various sectors where smart manufacturing, agriculture, smart buildings, and mobility could contribute more than 70% of the total global emission reduction potential. Access to universal health coverage and education, improved energy efficiency, all are made reachable with the ICT revolution, as you know. And ICT makes it possible for us to anticipate fulfillment of the, you can see on the left side, the Global Sustainable Development Goals, commonly known as the 17 SDGs. Next slide, please. To go on, ICT and other technologies such as modern sensors, big data and artificial intelligence, and the Internet of Things, IoT, can contribute in aiding our transition to green economies by driving carbon emission reduction and thereby generating additional cost saving, revenues, and wider societal benefits. ICT's ability to deliver emission reduction will come from its smart application in the realms of efficiency in transport, energy, real estate sectors. This is particularly so in the Arab region, where many buildings, if you remember, were built within the last 2 years, generally using inefficient air conditioning systems and building materials that require vast amounts of energy to be maintained and run. Next one. ICTs are essential for delivering on the ambitious shared global action plan for sustainability. Some nations, particularly those with high urban populations, have done very well in terms of setting energy transition deadlines. We've heard the previous speakers during this week, and by making digitalization a national necessity. For example, the UAE is one of the most urbanized countries in the world, with almost 80% of its population living in urban areas in 2021. The urban population is forecast to continue growing and should reach about 91% of the UAE population by the horizon 2050, according to the United Nations. In the UAE, policy goals such as Vision 2030 and Vision 2050 are parts of UAE's agenda to increase energy efficiency in the UAE and help fight climate change. The country somehow is aiming to be 100% powered by nuclear, solar, and other renewables in order to substantially reduce its carbon emission. Next one. Even though UAE is relatively a small country, its oil-based economy and focus on infrastructure development has resulted in per capita emission of nearly 24 tons of CO2 annually. However, the UAE is well on its way toward driving the concept of a smart city to physical realization, with many programs and applications already in place to tackle the significant energy consumption caused by the unique constraints in the environment. Next one. Dr. Rashid, I'm executing your instruction to go on a fast track. Huh? So
you still have 3 more minutes, so you're doing good.
to overcome sustainability challenges in this region, okay. Two-pronged approach is required. First, ICT themselves should undergo transformation and be developed to be more environmental sound and less carbon intensive, and we can refer to the insight provided by the ITU. Secondly, ICT-enabled solutions like smart grids, smart building, logistic, and industrial process should be deployed to help transform the world toward a more sustainable and energy efficient future. Next one. As a part of the roadmap for adopting relevant solutions to suit the region, the Arab region, environment particularly concerning the value chain, it's important to first understand the entire energy value chain from power generation to transport, distribution, supply, and consumption. We then need to promote the cooperation between digital and energy stakeholders, so cross-sector collaboration, and conduct integration of energy system. System-wide digitization, cybersecurity, transparent and competitive market for digital energy services, and we ensure, without forgetting data privacy and sovereignty for the country, supporting the investment in digital energy infrastructure. These are also some necessary steps. Next one. I would like to conclude by talking about the imperative, because we cannot talk about sustainability without looking beyond Earth. So it is imperative to digitally transform and create, as I mentioned, new socio-economic. We have a micro, which is okay, thank you. So to create new socio-economic possibilities from this transformation, and we require accelerated investment and a close collaboration between government and the private sector, especially on Earth. But I am encouraged to leave you with the thought that within the larger context of sustainability environment, we need to be mindful of the fact that digital solution may also come and be dependent on not only on how innovation takes place here on Earth, but also in the space. Thus, discussion on sustainability is incomplete without thinking beyond the surface of our planet. The space help foster survival on limited resources and promote conservation of resources, testing new innovation. It is through space that we could imagine supporting global security and sustainability. Rapidly increasing investment in space has expanded the range of real-life use cases of space application, and it is an emerging fact that space will play an even larger role in allowing the world to communicate, monitor our planet, help make nations more resilient to, for example, natural disaster, and both natural and man-created threats, as well to meet global imperatives such as leaving no one behind with respect to connectivity and access to broadband communication. We may also come to rely on space for mining resources to sustain the development on Earth. So I'm hopeful that through a sustained, continued dialogue and deliberation, we can productively align ourselves in overcoming sustainability challenges in the region. And this may also be one way of retaining momentum on the fulfillment of the UN 17 Sustainable Development Goals. Dr. Rashid, thank you with that. And I would like to thank you very much and wish both the organizer and participant successful outcome from today's discussion. Thank you again.
Thank you so much. That was an eye-opening discussion and conclusion, the slide we are looking at right now. Really appreciate that. I have taken some notes out of that myself. With that, we will proceed to the next presenter, Jeffrey Bayer. Jeffrey, you're with us? Do we have Jeffrey with us? Last but not the least, presentation. Let me check the names. If I see Jeffrey from Managing Director of the Zest Associates. I'm looking at the names, I'm going through the names, and I don't see the name Jeffrey. Okay. Maybe the tech support or any admin people, if you can try to have a quick contact with Jeffrey if he's trying to join. I'm not sure if Muhammad or Hussein, if you are here. Okay, Amira, you're reaching out. Okay, Amira is helping out. So meanwhile, till we get a feedback or information from Jeffrey, which will be the last but not the least presentation for today. If you guys have noticed, we've changed it to the 15 minutes. And something interesting, Bokar was saying that we should open up our horizon of interest or attention beyond the Mother Earth. Very interesting. I like that. It's amazing on how we spend billions and billions right now and the huge competition trying to go out of space, right? All different countries, even private companies right now, they're we are competing to go out of space. So what is the first thing we are looking for when we are going out of space?
Dr. Rashid, thank you very much for asking this question. I did not want to go deeper into the subject, but we can summarize it on 3 points. When we talk about sustainability, we have to be mindful about sustainability for the investment. As you rightly mentioned, that we have not billions, trillions of dollars in terms of investment going into space. And for the investor and the shareholders, or even for the capital market, we need to generate return of investment. So sustainability of the investment, sustainability from the debris management, because we have a number of elements going to space, and we don't want to have anything on our face tomorrow or for the next generation, and sustainability of the pollution. So these are the 3 aspects on which, of course, stakeholders like MBRSC, Mohammed bin Rashid Space Center, and many other space agencies are looking at, and we are trying from the UAE to bring all stakeholders and all nations together to address it and submit our resolution to the United Nations. So this is to answer your question. Thank you.
Absolutely. You mentioned the sustainability of the pollution. That's very interesting. I like the issues that you're addressing here. Obviously, we know that the pollution has no boundaries, and everyone is talking about the sustainability, and everyone is addressing the results of achievement from their sustainable development related to the 17 goals, but we still know that there is a pollution, and we still accept that the pollution has no boundary. So if there is a pollution and pollution has no boundary, that means, are we doing any good in the sustainability, right? As a overall global, from global perspective?
Let's say we are making some good progress, and I think some outcome will come from Sharm el-Sheikh, as in November we have the COP26. The UAE will be hosting COP27 in probably Dubai next year. So I do not want to anticipate the outcome of those head of states level meetings. But what I can tell you is that in terms of where do we stand, I believe we are on the right track. At least from the Arab nation, we have made great effort in our development, in our digital development, to respect our commitment that we have made with the Paris Agreement.
I love that, love that. And I see Jeffrey here. Jeffrey, how are you? Click on that mic button thingy, click on it. We cannot hear you, you're muted. Okay, I still cannot hear you. Is anyone else able to hear Jeffrey? I'm not able to hear you.
Yeah, I saw him remove the mute, but I still can't hear him.
Yeah, we cannot hear you, Jeff. No, not yet, not yet, not yet, not yet. Earlier, we were saying that if you have a problem, sometimes a hammer might be helpful, but I think that even is not helping you. So we still cannot hear you. See what you can do with your with your system. You might be unmuted, but the mic has no volume, right? No. Where are the IT guys? IT guys. Okay, now you're unmuted, but we cannot hear you. No, not yet. You want to go and come back? I think that's what you said. Okay, go and come back. Okay. So I think he's logging out and logging back in. So, you know, for past two years, we got so much used to screen that even we can understand when people do this, we learned what that means. Being so much exposed to the online meetings, online gatherings. So we will hold on a little bit more for Jeff to log off and log on back again. Hanging in there, please. not the least, but the last presentation. And Jeffrey has a very good subject to talk about. But let me introduce him. He is the managing director of the ZES Associates, and he's going to be talking about priorities to accelerate clean hydrogen and transition to green economy. So that's an interesting subject. Jeff is back.
Thank you. Can you hear me now?
Hey, we can hear you. That's great. That's great. So I was just telling everyone who you are, which company, and the subject that you're going to be talking about. So you are, yeah, you can start. You can upload your document, and we are anxious and excited to hear from you.
Excellent. Thank you very much. Thank you very much. It's really, really great to be here, and I appreciate the opportunity.
Jeff, 15 minutes. So if you can just like keep that timing, I will try to remind you. Okay. Yalla, go on.
Listen, thank you very much for the opportunity. I'm really excited to be able to talk about this subject today. I recently released a big report on UAE, UK clean hydrogen collaboration opportunities, and want to just really take you through very briefly a canter through the kind of conclusions and what we found. So this is what I'll talk about today, looking at an overview of the sector. We'll dive straight into the 7 priorities across 7 areas and look at a path forward. Next slide. So what do we mean when we look about hydrogen? What is this all about? I mean, we're talking about this all the time. It's some special gas. Why is this topic so important? Why are we always talking about this? And it's because of hydrogen's extreme versatility. So hydrogen can be used across virtually all sectors. It can be used for mobility in the transport sector. It can be used for electricity generation and also for storage. Hydrogen can be used in buildings for heating. It can also be used in industry for heavy industrial processes, for chemical manufacturing. So hydrogen is a very, very versatile gas. These are all the places it can be used. Not that it should be used necessarily, but that it can be used. But the thing is that hydrogen is a versatile form of energy, but it's just an energy carrier, okay? It's not an energy source. So hydrogen needs to be manufactured, okay? It has to be manufactured, and that means it's inherently inefficient. So if you can see any of these things on the left-hand side, wind, solar, nuclear, gas, other types of electricity generation, if anything on the right-hand side can use that electricity directly, then it probably should. You probably shouldn't go through this middle process of making hydrogen to do these things on the right, if you can just go straight from this energy source to this productive use, okay? Hydrogen as an intermediary necessarily means that you're losing some kind of energy in that transformation process. So if you can do these things without hydrogen, do it. If you can't, then use hydrogen. Okay, that's my kind of overall message. In terms of versatility, I've just put up here how these different sectors interact with hydrogen from both a supply and a demand perspective. And it really shows why hydrogen is such a challenging market to get off the ground to begin with. There are no kind of coordinating mechanisms between these different suppliers and demanders at the moment. People who work, in a petrochemical facility don't necessarily speak with people who will demand hydrogen from the rail industry, right? People who work in transmission and distribution lines don't often talk to farmers. So we have this challenge about coordinating all these different sector players from both a supply and a demand perspective. And this is one of the reasons I think that hydrogen is facing some of these early teething problems and becoming a bigger market. And it's true that hydrogen wasn't on the tip of everyone's tongue 2 years ago, and today everyone's talking about this new and exciting sector. So what is it about this sector that's really changed? It comes down to 3 things in my opinion: climate change, costs, and strategy. From a climate change perspective, we all know how mainstream climate change has become. I've worked in this space for about 18 years and am delighted to see the degree to which climate change is now a big concern for governments and people. We're also seeing how net zero is really starting to bite. And by that, I mean, we're moving towards a net zero position where some of the lowest hanging fruit, like easy energy efficiency and replacing coal with renewables, that fruit has in many cases already been picked. And we're starting to look forward into the more challenging decarbonization issues around heavy industry, shipping, aviation, for example. So So net zero is really starting to bite, and we have to figure out how to decarbonize these other sectors. In terms of costs, the biggest input cost to make hydrogen is energy. Renewable energy costs have fallen tremendously over the past 10 years, which means that hydrogen costs are also able to come down. So with a more competitive energy input, we get more competitively priced outputs of hydrogen. We've also seen the cost of gas and oil, very volatile over the past while because of the conflict. So hydrogen is in comparison seeming like a more competitive fuel source. In terms of strategy, there are again two main drivers here. From a demand perspective, we're looking at energy security, so we can no longer necessarily rely to the same extent on international shipments of gas like we could in the past. Hydrogen helps to improve energy security if we can diversify our energy sources. From a supply perspective, diversification, especially from oil and gas producing countries like the UAE and the Middle East more broadly, hydrogen provides an opportunity to diversify our economies towards something that actually has a place in tomorrow's low carbon future. These are, I think, three of the keys that are driving this interest in hydrogen. MENA is, Middle East, North Africa is an emerging hydrogen hotspot. And I'll tell you why. There are kind of three things: resources, geography and economy, and industrial composition. In terms of resources, the MENA region has incredibly abundant and low-cost renewable energy. There's lots of available land and good geology for carbon sequestration. This is relevant for blue hydrogen made from gas and sequestering the CO2. In terms of geography and economy, as I mentioned, there's an existential need to diversify the economy away from oil and gas and towards other low-carbon industries like hydrogen. There's already established trade routes between supply centers like the Middle East and demand centers, especially in Europe and Southeast Asia. And there's this reasonable proximity to demand centers. So we're not super far away like Chile or Argentina from the rest of the world. The Middle East is relatively close to many parts of the rest of the world. In terms of industrial composition, there's a real crossover in terms of skills between the oil and gas sector and the future hydrogen sector. The Middle East has lots of huge companies with big budgets, which are needed to build this incredibly expensive infrastructure. And it's one way really to bottle and ship all the great renewable resources that we have here in the region. Hydrogen can be that carrier. Super fast overview of why this is important and what's happening. Now let me take you through some of the findings we got from this major study that was released earlier in the week in partnership with HSBC and the World Green Economy Organization. The study is called UK-UAE Clean Hydrogen Collaboration, and I'm very happy to send you this report. It's also on the World Green Economy Organization's library of reports. Feel free to add me to LinkedIn if you want this report or to talk about it in the future. I'm going to take you through these 7 areas of priority that we looked at. And again, I know we're short on time, so I'll do it quickly. We looked, first of all, at policies. What kind of policies should be pursued? There are many different ways to support hydrogen. Directive policies mean, outlining the places in which or the sectors in which hydrogen should be used. Free market approach looks at just leaving it up to the market, kind of producing hydrogen and having the market decide where it's used. We asked respondents, should we try and stimulate demand, stimulate supply? What's the main priority here? And we found that respondents to a survey, there was over 60 hydrogen experts responding to this survey, and the questions were based off of roundtables held with about 40 experts across policy, innovation, investment, and trade. The answer was that was directive policy. They really wanted governments to say where and how they saw hydrogen contributing to the country's net zero trajectory. And when you look at the Middle East, we know that there's significant policy actions already happening. In Saudi Arabia, there's a strategy being developed. It aims to be the world's largest hydrogen producer. In the UAE, the strategy was launched in terms of its development in August of this year, will be released early next year. The UAE aims to capture 25% of the global market share. And it's cleverly split the responsibility of hydrogen between green and blue for Masdar and ADNOC. When you look at Oman, for example, they're looking to attract $34 billion of investment and create almost 150,000 jobs in hydrogen. So it's a huge drive there. In Egypt, likewise, the hydrogen strategy was released in, supposed to be released in June. It's late, but again, they expect it to be a huge market. And Egypt's particular proximity to Europe makes it an especially good place to start an undersea hydrogen pipeline to transport hydrogen from Egypt into Europe. Turkey is a bit behind the curve. So if you're interested in Turkey, it's probably not going to be a hydrogen production hotspot. Turkey has enough trouble producing its own power domestically, so diverting that to hydrogen production is unlikely. But this is the kind of policy picture at a high level in the Middle East. We looked at how demand should be supported. This is one of the highlights of the policy conversation. This means how do you encourage people who would consume hydrogen to consume it rather than to consume some alternative like gas or electricity? The biggest driver that respondents thought would encourage consumption of hydrogen is carbon pricing. And the reason for that is because ongoing fossil fuel subsidies and a lack of carbon pricing skews the market in a way that is disadvantageous for hydrogen. So it advantages gas and disadvantages hydrogen by taking away that avoided cost of pollution, which is essentially a carbon price. By putting a carbon price on gas, it makes hydrogen more competitive with gas. Also popular in this area is setting national and corporate net zero targets. That means that companies and organizations can define how hydrogen is going to be used in their net zero trajectory. And when you look at cost as being a challenge for consumers, this is indeed a big issue. When you look at low and high costs for hydrogen, gray, green, and blue, you can see that they don't really compete at the moment for when you compare it to, for example, gasoline. So a kilogram of hydrogen gets you roughly as far in your car as a liter of gasoline, but a kilogram of hydrogen costs 10 to 15 pounds in the UK, $16 in the US, versus just a couple of pounds per liter of gasoline in the UK, or even like $1 a liter in the US. So we're way off in terms of cost competitiveness, and that's definitely a huge challenge. When we look at how supply should be supported, this is how we can support producers of hydrogen. Offtake agreements is the most important thing. An offtake agreement is basically something that commits a buyer to buying hydrogen over a long period. There's many reasons why actually buyers aren't really keen on signing long-term offtake agreements. The expectation for cost reduction in hydrogen is very high, so there's a high likelihood that hydrogen produced 5 years from now will be much cheaper than hydrogen produced today. That makes the incentive to sign a 25-year contract to buy hydrogen at today's prices very unlikely. So there's a whole number of reasons why offtake agreements aren't being signed, and that's definitely something that would stimulate the market.
Jeffrey, so we have 3 more minutes.
Perfect.
Yeah, thank you.
I'll canter through it. We're looking at investment as well, and I'm actually just going to slip to the next slide because I think it's a little bit more interesting about investment. And it's about the volume of investment that's required to reach net zero. By 2050, we're looking at energy demand roughly doubling. Hydrogen is expected to make up between 15 and 24% of that future energy demand. So imagine that if every house you see, every 4th house is dedicated to producing hydrogen, every 4th plane is dedicated to producing hydrogen, it's a huge amount of demand. And it requires a huge amount of investment. Okay, 1.2 trillion by 2030 and 10 trillion by 2050. Okay, when you compare that, actually, it's a huge number. When you compare it to the amount of energy or investment required for the energy transition, it's substantial. Almost 40% of the total energy transition budget is for hydrogen. Okay, a ton of investment is required. We looked at infrastructure as well, and I'll just go very quickly. There's not a huge amount of consensus on what infrastructure is required, but when you look at the infrastructure types, it looks like this. So you've got 3 types of investment. Really, the first one is upstream infrastructure, which requires about 25% of the investment. Downstream infrastructure like transmission, distribution, and storage, about 15%. But the bulk of the investment, interestingly, comes in this end use. So it's not about producing hydrogen or even about shipping it around. It's about using that hydrogen at the end. And that's where a lot of the money is going to go. New hydrogen vehicles, ships, planes, trains, industrial applications, and factory retooling. Okay, that's where most of the investment is going to go. 3 more slides, just to keep you comfortable. We're looking at what should the focus of innovation be. Really, commercial scale pilot projects is absolutely critical, and that demonstrates that hydrogen can be scaled up and the supply chain is in place. And if we really innovate, if we dedicate ourselves to innovation, we can probably see cost curves for hydrogen come down like this. Every week, I'm seeing in the news another breakthrough, a breakthrough in hydrogen production, a breakthrough in hydrogen storage and transport. It's a very, very exciting space. And I think when the world kind of focuses their collective action and effort on innovation, like we did during the COVID pandemic and got a vaccine in a year, I think we're going to see a similar type of major cost reduction in hydrogen now that every country is on board and really going for it. Again, skills, you can look at that on your own in the report. Final slide here, what's on the horizon? In the short term, I think we're going to see a national ramp up of targets. We're going to see heavy investment in R&D, big partnerships announced. I see in the medium term, actually, a bit of uncertainty coming. Maybe this hype around hydrogen might not deliver. Is there going to be a lack of skills? Is there technological challenges to scale up at the speed and scale that we want? I think that will all come in the near future. But we're going to see a lot of novel technologies and market disruption from breakthroughs. It's in 2030 onwards that we see this accelerated build out, really clear national and regional leaders emerging. I hope the Middle East and the UAE are 2 of those regions and countries that really accelerate this future. And I think we can see fiercer competition from renewable energy and carbon capture and storage. That was extremely quick. I appreciate your time very, very much. I encourage you to add me to LinkedIn, go onto the website and download this report. It's got a ton of really interesting information in it. And I really encourage you to do that. Thank you very much for your time.
Thank you so much. Earlier, a few minutes ago, we were talking with Bukar about we are spending trillions of money looking for oxygen in the space. Now Jeff is telling us we are going to be spending billions of money looking for hydrogen on the earth, So this is very exciting, very interesting. I think soon we're going to be breathing hydrogen. But very well, thank you so much. We appreciate that. And at this time, I would like to request Bushra from Clean Energy Business Council Limited. If you would please share your thoughts.
No, I just wanted to say a few words. First of all, thank you so much, Mr. Jeffrey, for this very nice presentation. Thank you, Dr. Rashid, for leading this session today. It was very fun with you. And I just want to thank again the speakers and the participants for this very nice week. It was very informative. I'm very, very happy with what we have organized in collaboration with the Environmental Center with Arab Towns. We will share the recordings and the presentations as soon as we have them. So just wanted to say that to thank everyone.
I lost the voice.
You can hear me?
Oh yeah, okay, yes.
So that's pretty much it.
Great, and we thank you, and we thank the Clean Energy Business Council Limited and the Environment Center for Arab Towns and everyone. So this concludes the 5th and the last day of the event. And I don't know how we're going to keep in contact, maybe through the LinkedIn. Yes, everyone is there. So
Yeah.
we could do that. And with all that, you all guys have a nice weekend ahead. And what's for lunch? What's everybody eating for lunch?
We'll see.
Is it hydrogen or oxygen? What fuel are you using?
Thank you very much. Thank you indeed.
Thank you so much. So then, yeah, so if there's anything anyone want to discuss, but you're also more than welcome to leave the session, as this is officially the end. But we will be here, and if there's any further discussions, we are like the captain of the ship, so we're gonna have to stay till the last passengers taking the boat out. So, right. Okay, so yeah, so with all that, so everyone, we hope that you had a good time, enjoyed, and got to know a lot of other colleagues, professionals, and benefited from the presentations. This is officially the end.
Hopefully
You are more than
next year it will be physical. Hopefully.
I would love to see that. Just 2 days ago, we had a physical session on Sustainability Award, and it was just totally
we missed that.
Yeah, so we really need to go back to that. I know we've got so much used to this screen, so much used to it, but yeah, at least we move a little bit, watch our weight. We get to eat more when in the physical sessions, but yeah, but things that's actual regular gatherings, physical gatherings, workshops is actually happening now. So as I was saying earlier, the whole discussions before and after the events, which are always much more effective in interaction, getting to know to people, the networking, of course, in addition to actual presentations. But that's exciting. Today was very exciting. I wasn't able to attend the previous ones, but the oxygen and we ended up oxygen and hydrogen. So
yeah, they were also very nice and very informative. Inshallah, we'll have them for everyone.
The Clean Energy Business Council, you are based in Dubai, right?
Yes, yes.
Okay, very well, very well. Okay, anything in the chat here? Let me just open it up, see if anyone's saying anything. No? Okay, everyone who's saying thank you, you're most welcome. تفضل. صوت مش واضح. منو معنا؟
حسين الفردان معك. واضح؟
هلا اخوي حسين تفضل.
واضح؟
هي واضح.
واضح.
أتقدم بالشكر إلى الأخوة مجلس صناعات الطاقة النظيفة وإلك وإلى جميع المتحدثين اللي استضفناهم خلال الأسبوع. كان أسبوع طويل ومرهق. الشكر موصول إلى فريق العمل يعني بقيادة الأستاذة بشرى، الأخت أميرة، أحمد، عندنا رانيا، يوسف، الأخ محمد النور. فريق عمل يعني كان من خلف الكواليس يعمل الحقيقة لمدة شهرين متواصلين لحد ما ظهر هذا الإيفنت. نتمنى من جميع المشاركين يعني من يرغب أن يضيف أي بصمة، أي اقتراح أو أي حاجة يقدر يتواصل معنا، سواء مجلس صناعة الطاقة النظيفة أو مركز البيئة المدن العربية. أي ملاحظات عنده راح نحاول أن ننزل إن شاء الله أوراق العمل على الويب سايت لنا وللمجلس أيضا. الفيديو، نقل الفيديو أيضا راح يكون متاح على الموقع، وراح نتشارك مع الأخوة في مجلس صناعة الطاقة النظيفة. إن شاء الله الإيفنت يستمر، يعني شراكتنا مع المجلس في إن شاء الله العام القادم يظهر هذا الإيفنت بشكل أفضل، ونحاول يعني نتدارك أي يعني تقصير قد يكون غير مقصود. شكرا لكم ونلتقي على خير. شكرا لك دكتور راشد على حسن إدارة اللقاء.
العفو، لا شكرا على واجب، هذا واجبنا أخ حسين. اوكي، في ناس بعد موجودين معانا اشوف اساميهم، ولكن انتهينا نحن اليوم من المحاضرات. So yeah, we have already concluded the events. You are more than welcome to leave. حياكم الله.
I think you can leave Dr. Rashid.
Yeah, can I smell
Yeah.
the food? Okay then. All right. So bye-bye.
Thank you so much for today.
Welcome. Bye-bye.
Bye.
Thank you all. Have a nice
Bye-bye.
weekend. Bye-bye.
Have a nice weekend.
شكرا
Bye. Have a nice
للجميع.
weekend. شكرا.
ممكن كلمة؟